on to section 8.2, and section 8.2 talks about arithmetic sequences specifically. So you have already had some experience now with arithmetic sequences, which by the way, if you remember from last year, arithmetic sequences just mean linear sequences. So we've already talked about linear sequences, but this whole section very specifically talks just about that kind of sequence. The last section talked about lots of different kinds of sequences mixed together. So the first thing that I need to tell you is that arithmetic sequences are, or a sequence is arithmetic if the difference between the terms is constant. Arithmetic sequence yes, it's called arithmetic, not arithmetic.
Why not?
And that difference between the terms, we always note with a lowercase d. Do you guys remember that from last year? Lowercase d represented the differences between the terms. So if you have some sequence, a sub n is equal to a sub 1, comma, a sub 2, comma, a sub 3, dot, 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 you would find the differences by subtracting any two terms from each other. So for instance, you could take the third term minus the second term. You could take the second term minus the first term, etc., and you would always get the same number. And that same number is called D, D representing the differences. D is the difference between the terms. Alright, so let's say we have this situation going on. A sub n is equal to 3n plus 2. That's the rule for some arithmetic sequence. What's the difference? What is the common difference between all the terms? Yep, it's going to be 3. The common difference between. In other words, it's this number right here. That number we also call the slope. The slope, which is also called the differences. So in this case, the d value is going to be 3. So if you found the very first term, all you would have to do is continue to add 3 to get the rest of the terms. So let's quickly list what the terms are. What would be the very first term?
10.
3 times, the very first term would be 3 times 1, which is 3, plus 2 is 5. So the first term is 5. The second term is going to be, no need to now plug a 2 in for n. You just know that the differences are 3 now.
8.
So all you have to do is keep adding 3 onto it. So the next number would be an 8. The next one would be an 11, and then a 14, and then a 7, etc.
17, not a 7.
Did I say 7?
Yes,
Yeah.
yes, you did.
Oh, I'm sure I didn't say that.
I swear you did.
We can go back and listen to it.
We will.
17, okay? All right.
Have some in the future.
What about this? What if you had to find the difference of a sequence, and the sequence is this? You've got 3, and then the next term is 9/4, and the next term is 3/2, and the next term is 3/4, etc. And it's an arithmetic sequence, which means all the differences are going to be the same. So if that's the case, what is the difference? How do you find the difference? Remember what I said a minute ago, all you have to do is pick any one term and subtract from it the term right in front of it. So you could take 9/4 minus 3. You could also take 3/4 minus 3/2. You could take 3/2 minus 9/4, etc. Go ahead, get your calculators out, you guys. What is the difference between any two terms? What is 9/4 minus 3? What is 3/4 minus 3/2? What'd you get?
3/4.
Did you get negative 0.75? So as a fraction, you would get negative 3/4. Are you okay with this, you guys? I'm not getting a lot of response right now, so
Wait, we're supposed to take the term before.
Yeah, before it.
yeah, you would take this term, 9/4, minus the term right in front of it, minus 3. Yeah, we always subtract,
To the left.
yeah, subtract to the left.
Okay.
Yeah. Negative 3/4, all right. So what about 3/4 minus 3/2? You get the same thing? 3/4 minus 3/2. Do you get the same thing? Get the same thing, all right. So it doesn't matter. If you already know that it's going to be an arithmetic sequence, you know that the differences are always going to be the same. So I'm not suggesting that you have to check every single one. I was just showing you that it does work like that. All right, what about this? What if you have a situation like this, and I give you term 1, a sub 1. The very first term is equal to 12, and the differences are negative 2. And I ask you guys to write a rule. Write a rule for this situation. Write a rule. And usually the rules start off a sub n is equal to. Alright, the differences are negative 2. So the differences, that's another way of representing it's what? It's slope. So you know that the slope is negative 2. So you do negative 2, and what goes next to negative 2? An n. Remember, the slope always goes with the variable in a linear situation. And then we have a sub 1 is 12. So I just add a 12 onto the end?
Negatory.
No, you don't do that. Because this is the first term, and when you're writing a rule, you always need to give me the 0 term. So what I'm going to do here is just, the first term is 12. I'm going to list some terms here to help me think through this. The first term is 12. This one's not bad. I know some of you are like, we don't need to write these all out, but sometimes they'll be a little bit more complicated where it might be helpful to write them out. First term is 12. The second term is going to be 10. I know my differences are negative 2, so I'm constantly subtracting 2. The next number would be an 8. The next number a 6, and so on. So I need to work backwards one step. So if I work backwards one step to get the 0 term, what are you going to get?
14.
You're going to get a 14. So the 0 term would be 14. So we have negative 2n plus 14. So now what if I asked you guys to find the 172nd term? What would you do?
Put it in the calculator.
Plug 1 into the calculator.
That.
Yeah, you can type this in. This is like your y equals equation. Type this in, replace n with a, or make a table and replace it with whatever term number it is that you're trying to find. So if you want the 172nd term, you just go to 172 in your table, or you can just do negative 2 times 172 plus 14.
Negative 330.
Oh, thank you. I didn't really want it, but thank you.
Yeah,
What'd you say it was? Negative what?
330.
Negative 330. Okay. All right. What about this? I ask you to find a formula or find a rule if this is the situation. The first term, a sub 1 is equal to 7. And a sub 5 is equal to, the fifth term is equal to 19. That's all I give you. It's arithmetic. It is arithmetic, I will tell you that. So if the first term is 7 and the fifth term is 19, what's the rule? So this is what I do when I usually reason through these things, is I kind of set the problem up like this. I know the first term is 7. I do not know the second term. I don't know the third term. I don't know the fourth term, but I do know that the fifth term is 19. So I know that the differences between these two numbers has to be 1, 2, 3, 4 has to be split. I have to figure out the difference between the first term and the fifth term, and then I have to split it into 4 parts. Because this difference is not the difference between the first and the second term, it's the difference between the first and the fifth term. So you're going to take the very last term that you know, which is 19. 19 minus 7 is 12, but then that has to be split into the 1, 2, 3, 4 parts that I have. So I'm going to take 19 minus 7 divided by 4, which is 12 divided by 4, which is equal to 3. So my differences in this case are equal to 3. So this value right here is my D, which is also my slope. Good. All right, now, so when you're writing your rule, a sub n is going to be equal to 3n, but we still need to figure out what the 0 term is. So we need to think backwards 1 step. When you think backwards 1 step, you have to subtract 3. So when you subtract 3, you get 4. So the 0 term would be equal to 4, so 3n plus 4. Okay, clear? Yes? No?
There.
Let's do another one like that where you have to do more than just a few terms like that. Yeah, this stuff is not bad. Let's say that you have the 4th term. The 4th term is equal to 37, and you know that the 10th term is 28. 10th term is 28. So again, you might not need to do this, I don't know, but the 4th term is 37. I don't know the 5th, the 6th, the 7th, the 8th, the 9th, and I do know that the 10th is 28. So, take the very last term that you know, which is 28. Subtract from it the very first term that you know, which is 37. And then you have to divide it by how many steps there are from the very first term that you know to the very last term that you know. So, watch what I do though. Don't do this. You don't count the 37 as the very first step. You start at 37, you go to the next, that's step 1, 2, 3, 4, 5, 6. It took 6 steps. So you're going to take this answer and you're going to divide it by 6. So 28 minus 37. What is 28 minus 37? Divided by 6 then is going to give you a differences of negative 3 halves, I think.
Yep.
So I'm just going to use negative 1.5 because that's not a horrible difference, a horrible decimal value anyway. So my differences in this case are negative 1.5. So every step that I take to the right, I'm going to subtract 1.5. So 37 minus 1.5 is equal to 35.5. And then you could take 35.5 minus 1.5 again, that would get you 34, etc. So your rule, a sub n, is equal to negative 1.5, negative 1.5n, but we need a starting value here at the end. Remember this term, 37, is actually the 4th term. So we need to think backwards all the way to the 0 term. So I have to go backwards to the 3rd term, to the 2nd term, to the 1st term, and then to the 0 term. So I need to think backwards how many steps? You need to think backwards 4 steps. When I think backwards, every step is a what? The positive 1.5. So I have to go positive 1.5, but how many times do I go positive 1.5? 4. So you do 1.5 times 4. 1.5.
6.
1.5 times 4 is 6. So my very starting value is going to be a 6.
No, it's not. It's going to be 43.
Oh my gosh, I have to add, sorry, yes, I have to add 6. I have to add 6 onto 37. Thank you guys. Sorry. I'm so confident. Yes, add 6 onto 43. Thank you.
Nope, you had 6 out of 37. And you get 43. Because if you added 6 to 43, you'd get 49.
Yes, listen to what I mean, not what I say, okay, you guys? Add 6 onto 37, you get 43. Thank you.
This is a fun session.
All right, your job, actually, I think I'm going to keep going and give you guys, actually, yes, another example. Let's say that A1 is 17. The very first term is equal to 17, and that the recursive rule A sub k plus 1 is equal to A sub k minus 7. And I would like you guys to figure out the first 5 terms, the differences, and then also write a rule, like write a y equals rule. So the very first term is 17. So the first 5 terms are going to be 17, comma. How do I find my next term? Subtract 7. It says to figure out the next term. This is like this a sub k plus 1 is like finding your next term. A sub k is the term that you have right now. So you are taking the term you have right now, and you're subtracting 7 from it. So 17 is the first term, minus 7 is 10, minus 7 again you get 3, minus 7 again you get negative 4, minus 7 again you get negative 11. So there's your first 5 terms. What are the differences? What are your d values?
7.
You're always subtracting 7, so the d value is equal to negative 7. And your rule, a sub n, is equal to, well, your differences are negative 7, so it's negative 7n. Then you have to think backwards 1 step to get your 0 term. So if you think backwards 1 step to get your 0 term, you have to add 7. So it's going to be 24. All right. Now I would like to, I'm debating right now if I want to go on to this, and I think I'm going to. Let's go on to this. We are going to talk about how to find the sum of a finite arithmetic sequence. So,
Is this still 8.2?
yep, still 8.2. Now, up until now, if I gave you guys a sum, you pretty much have either relied on your calculator to find the sum, or you have had to find each term and then add them all together. But there's a rule that you can use if you have a arithmetic sequence, and we did talk about this last year. But I want to tell you a little story first of all about a mathematician by the last name of Gauss. I can't think of his first name off the top of my head, but he's a very, very old mathematician, dead many years ago. But
How old? How old would he be today?
I don't know.
He's like you.
I bet he would be 14.
Anyway, a long time ago, he was in school, and his teacher, the way that I've heard the story, if I've heard it correctly, is that his teacher had given all the kids in his class, by the way, he went to a one-room schoolhouse, and everyone that he went to school with was a boy, because I believe that girls weren't allowed to go to school back then. But his teacher had asked everyone in the classroom to find the sum of the first 100 integers. So in other words, add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, just to keep him busy for a while because she needed to get something done. So she gave him some busy work, told him to do it, and this mathematician by the last name of Gauss very, very quickly figured it out in his head, or scratch work or whatever, and a couple minutes later brought it up to the teacher and said the sum is blah, 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 whatever the sum was. And we will figure out the sum in just a minute. But, and this is what he did. he said, okay, well, if you want me to add together the numbers 1, 2, 3, 4, 5, all the way to 100, that means we've got a bunch of numbers, 1, 2, 3, 4, 5, a bunch of numbers, and then 97, 98, 99, and 100 at the end. This is how he finished it off. So this is what he did. He said, okay, well, if I add together 1 and 100, what do you get when you add together 1 and 100?
101.
You get 101. And then he said, okay, well, if I add together 2 and 99, what are you going to get? You're going to get 101 again. And then he said, okay, well, 3 and 98, what's 3 plus 98? Also 101. You see where he's going with this? And he continued, I mean, at some point, since he did it so quickly, so he realized that he didn't have to figure out every single one of these things. He just kept adding in and adding in and adding in and adding in and adding in. What was the very last two numbers that he had to add together?
50 plus 51.
Yeah, so he added together 50 and 51, which got him what?
100.
100. How many times did he multiply it by 50? What is the sum of the first 100 integers? So 5,050. So if you added 1 plus 2 plus 3 plus 4 plus 5 all the way to 100, you would get 5,050. So this is the deal. All he really had to do was he had to take the very first number, which was 1, and add to it the very last number, which is 100, multiply that by, no, I think what he did, the rule says this, you actually multiply that by how many numbers there are, which is 100, but then divide that by 2. What does the 100 and the 2 do when you divide it? You're multiplying by 50. So he's taking the 1 and the 100, getting 101, and then multiplying that answer by 50, which gets you 5,050. So, that said, this formula for finding the sum of an arithmetic sequence, is this arithmetic, you guys? 1, 2, 3, 4, 5. Why is it arithmetic? You're constantly adding 1 to get to each next number. What's the slope of this sequence?
1.
Slope is 1. So, the rule that has evolved out of this is that if you take the very first term, you add to it the very last term, you multiply it by how many terms there are, and divide it by 2, you will get your sum. So it's the first plus the last times the number of terms divided by 2. So let's write that formula down because you were going to need to use that. To find the sum, S sub n, that's what the S sub n means. To find the sum of an arithmetic sequence, you take the very first term, a sub 1, plus the very last term, which we'll call a sub n, because the very last term depends on the problem. You multiply that by how many terms there are, and you divide it by 2, and that will get you your sum. So, do you feel like we should go over an example of that formula? Or do you feel like you
Yeah,
could...
just one.
Just one.
Yeah.
Only one. I feel like we already did half our homework problems already, so.
All right, so let's do an example. Let's do this. I'm going to give you a rule. A sub n is equal to, let's do negative 3x plus, let's do negative 3, not x, n, negative 3n plus 7, and let's find the sum of the first, how many terms do you want to add together?
99.
The first 62 terms I heard. So you could figure out the first term, then the second term, then the third term, and the fourth term, and add together all the way up to the 62nd term. But instead of doing that, all we really need to do according to the formula is find the first term. So help me find the first term. Negative 3 times 1 is negative 3, plus 7 is 4. First term is 4. What is the 62nd term?
Negative 170.
Negative 179.
79.
Agreed?
Just taking a guess.
Alright, so to find the sum, you need the first term, which is 4. You need the last term, which is negative 179. We have plus negative 179. You multiply that by the number of terms. How many terms are there? 62. And then you divide that answer by 2. So 4 plus negative 179 times 31 is really what you're doing. What is it?
Negative 5,425.
5,425.
Negative, yeah. She wrote it.
I wrote it and didn't say it. Negative 5,425. Alright, I gotta say this. What happens, what if I ask you to do this? If I ask you to find the sum of something, and I ask you to go from the 4th term all the way up to like the 97th term, what happens then? I mean, you do it the same way. You're still gonna take your first term, and when I say your first term, I don't mean term 1. I mean the first term that you are trying to figure out. So you would take the 4th term first. Does that make sense?
Yes.
You take your 4th term plus you figure out your 97th term. You multiply that by how many terms there are divided by 2. Now, that's why I wanted to talk to you about this. How many terms are there in this sum?
98. Oh wait, no, there's
How
not.
many terms
There's 94.
are there? What'd you do to figure that out?
I don't know if that's right. Is it?
97 minus
Yeah, I know, but you have to count the 4th term, so.
Exactly,
it's
yes. You have to add 1 onto the end. So how many terms are there? You take the very last term, which is 97, minus the 4 from it, but then you have to add 1 onto it. Because when you just take 97 minus 4, you're not including the 4. You're not including the 4th term. So make sure when the bottom number, when this bottom number right here does not start with a 1, that you subtract 97 minus 4 and then add 1 onto it. So 97 minus 4 is 93 plus 1 more term. There would actually be 94 terms. So the reason I'm telling you that is because when you use your formula, n is not going to be, in this case, would not have been 97. Your n value would have been